In this video, we continue the review for final. Number 27, 3y cubed plus 15y. We need to factor this binomial. This binomial has two terms, 3y cubed and 15y. In order to factor this binomial, we need to look at the two terms in the binomial to see what's the GCF of the two terms. GCF of the first term and the second term. We look at the coefficient of the two monomials. They are 3 and 15. Anyone tell me what's the GCF of 3 and 15? Very good. Special case number 1, right? Awesome. And then we look at the variable parts of the two monomials. They are y cubed and y. What's the GCF of y cubed and y? Y, yeah, take the lower exponent. Awesome. So the GCF of the two terms in the binomial is 3y. Once we found the GCF of the two terms, we are going to factor the GCF 3y from the binomial. Original polynomial is a binomial. After we factor out the GCF inside the parentheses, we should still have a binomial. Yeah. How do we find the binomial in the parentheses? So if you think about the first term, original term 1. Original term 1 is y cubed, is 3y cubed, 3y cubed. And the 3y cubed is 3 times y times y times y, right? So it's 3y times y squared. Yeah, 3y cubed is 3 times y, and then times y times y. Y times y is y squared. So if you factor out 3y in red, does that mean the leftover factor for that term is y squared? Yeah, okay. So you have y squared from the original term 1. And then let's look at the second term, 15y. 15y is 3 times 5 times y, right? Yeah. So it's 3 times y times 5. You can see 15y as 3 times y times 5. So if you factor 3y out, what's the leftover factor from the term 2? 5, positive 5, exactly, very good, positive 5. So that's the leftover term, factor in the second term. So in the parentheses, the binomial is y squared plus 5. And that's the final result. That's how do we factor out the GCF to factor this binomial. Yeah, we factor this binomial by factoring out the GCF of the two terms in the binomial. Any questions? Yeah. Number 28. Let's see number 28. We are going to factor this polynomial. This polynomial is x cubed plus 5x squared plus 4x plus 20. How many terms in this polynomial? 4. Remember, if we have 4 terms in the polynomial and we need to factor it, what's the method we should apply? What's the method should we apply to factor a polynomial with 4 terms? What's the method? Don't remember? Factoring by grouping, right? Yeah, factoring by grouping. Yeah, factoring by grouping. The 4 terms seems too many. So we group them. This is how do we group them. We're gonna group the first 2. Remember in the class I said always try the first 2 and the last 2. Most of the time it always work. So we group the first 2. We color is blue. And then we group the last 2 terms as group green. Yeah. So we group them. We divided the 4 terms into 2 groups. From the blue group, What's the GCF of the two terms in the blue group? X cubed plus 5x squared. What's the GCF of the two terms in the blue group? Perfect, x squared. And if we factor out x squared, what's the leftover factors in the parentheses? Perfect, x plus 5. Very good. So let me color this as a blue. For the green, we're going to do the same thing. The green group has two terms, 4x plus 20. What's the GCF of 4x and 20? 4. So we factor 4 out. What's inside the parentheses? X plus 5 again. Very good. And that's what we want. We want the two groups have something in common. Now we did find the thing that is in common, which is the common binomial factor x plus 5, right? Do you see what I'm talking about? Yeah, let me make it darker. Yeah, x plus 5 is the common binomial factor. Yeah. So we're gonna factor out the common binomial factor from the two groups. We factor out x plus 5. And inside the parentheses, from the blue group, if you factor out this guy, and this guy will be left, right? So from the blue group, you will have x squared left. Do you see what I'm talking about? Yeah. From the green group, you factor out this part. Then the leftover factor is 4, right? 4 will stay in the green group. So inside the second parenthesis, the second term will be 4. And x squared plus 4 is a prime, is a sum of two binomial, is the sum of two squares is a prime. So you need to make sure this is a prime, this is a prime. You wrote the original polynomial as a product of two lower degree polynomials, and each single of them are prime. This is prime, this is prime. So you are done. So the original polynomial is factored. That's the result you need to choose, okay? And from A, B, C, D, you're going to choose this one. There's a trick that you could take advantage of the multiple choice question of the test. You can FOIL, if you FOIL the answer choices and the result gives you the original polynomial, then that means the answer is probably is correct. Any question about number 28? If not, number 29. We need to factor x squared minus 2x minus 3. This is a quadratic trinomial with leading coefficient 1. All right, when you see a quadratic trinomial, when you need to factor a quadratic trinomial, you always start from identify A, B, and C. What is A? What is B? What is C? Yeah, so what's the name of the method we apply? We learned from the class to factor a quadratic trinomial with leading coefficient 1. What's the name of the method? Shortcut method, right? Yeah, nothing extra. Every step is necessary. So you're going to go ahead to find the two numbers, two integers whose product is C, -3, and whose sum is B, -2. Determine the sign first. Since the two numbers multiply to a negative number, one is a plus, the other is a minus. Since the addition is a negative, the negative number has a bigger absolute value. The positive number has a smaller absolute value. So let's see how do we handle that. Absolute value of -3 is 3. The only way to factor 3 is 1 times 3. And the negative number has a bigger absolute value. Let's try -3, +1. Do the two numbers satisfy the two conditions? -3 times +1 is -3. -3 plus +1 is -2, right? Yeah, those are the two numbers. They are the -3 and the +1. -3 and a +1. how do we use the two numbers to get a factorization? Is very straightforward. Parentheses times parentheses. Inside the first parenthesis, you have x plus the first number plus 1. Inside the second parenthesis, you have x plus the second number minus 3. Here we go. That's the result. All right. Number 30 is the same thing. To factor a quadratic trinomial with leading coefficient 1, let me copy it. It's x squared plus x minus 6. Why do I give 4 different problems for shortcut method? Because of the sign. There are 4 problems, same type of problems. All the 4 problems are factoring a quadratic trinomial with a leading coefficient 1. But the signs of the two numbers are different. So those are the 4 different cases. Number 30. Tell me please, what is A, what is B, what is C? 1, 1, -6, right? So make sure the leading coefficient is 1, and then you go ahead to apply shortcut method to find the two numbers whose product is -6, whose sum is 1. Which two numbers? One is positive, the other is negative, right? And the positive number has a bigger absolute value because the addition is positive. So for 6, we have 6 equals 1 minus 6, 2 times 3. So 6 equals 1 times 6, or 2 times 3, and that's a negative, you said positive 3, -2, right? Positive number has a bigger absolute value. Yeah. So it's a positive 3 and -2, right? Yeah. Those two numbers multiply to -6, add up to 1. Okay, so the result, the factorization of the trinomial is parentheses times parentheses. Inside the first parenthesis, you have x plus the first number. Inside the second parenthesis, you have x plus the second number. Here we go. Number 31. Let me copy number 31. It's 8 and 7. X squared plus 8x plus 7. Okay, tell me please, what is A, what is B, what is C? Very good. Yeah, leading coefficient is 1, so go ahead, shortcut method, find the two integers whose product is C, whose sum is 8. Positive, positive, right? Yeah, their product is positive, their addition is positive. That means the two numbers are both positive. Since 7 is even, since 7 is prime, the only way to factor 7 is 1, 7, both positive. Positive 1, positive 7, right? Yeah, they do multiply to 7, add up to 8. So the original quadratic trinomial could be factored as parentheses times parentheses. Inside the first parenthesis, we have x plus 1. Inside the second parenthesis, we have x plus 7. Here you go. Number 32. Case 4 of a shortcut method. Let me get a problem. 32. It's negative 1130. Negative 1130. X squared minus 11x plus 30. Yeah, tell me please, what is A, what is B, what is C? Awesome. Make sure the leading coefficient is 1, so we go ahead and shortcut method. Find the two integers whose product is C, whose sum is negative 11. Since the product is positive, the two numbers must have the same sign, either both positive or both negative, right? Since the addition is negative, they both are negative. They are both negative, yeah. And which two negative numbers? We factor 30. 30 could be 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. And you can see only one case works, right? Yeah, -5 and -6 add up to -11. So the two numbers are -5 and -6. always take time to double check. -5 times -6, positive 30. -5 plus -6, -11. So the original quadratic trinomial with leading coefficient 1 could be factored as parentheses times parentheses. Inside the first parenthesis, you have x plus the first number with the sign. Inside the second parenthesis, you have x plus the second number minus 6. All right, so those 4 problems are all about factoring a quadratic trinomial with a leading coefficient 1, shortcut method. Very, very important. Number 33. Let me get more space. Number 33 is to factor a quadratic trinomial with leading coefficient different from 1. What's the method we learn to factor a quadratic trinomial with leading coefficient different from 1? Tell me please first, what is A, what is B, what is C? Very good. Leading coefficient is different from 1, right? The method we learn is called slide method, right? Yeah. Actually, I posted a video. The video has 3 different methods. If you watch the video, you can learn all the 3 different methods. But in the class, we only use that method, slide method. Okay, we're gonna slide the coefficient, leading coefficient away to multiply with the constant to create a new trinomial. So we have x squared minus 13x plus 36. Because 6 minus 6 is 36, right? Yeah. For this blue one, for this blue trinomial, we have a equals 1, b equals -13, c equals 36. Shortcut method, we go ahead to find 2 integers whose product is 36, whose sum is -13. The 2 numbers would be -4 and -9. -4 times -9 is positive 36. -4 plus -9 is -13. So the blue trinomial could be factored as parentheses times parentheses. Inside the first parenthesis, we have x plus the first number. Inside the second parenthesis, we have x plus the second number. And then divide. Divide what by what? Divide the 2 numbers in red by the original leading coefficient. What's the original leading coefficient? Well, the leading coefficient of the original trinomial. What's the number in the bubble? Yes, 6. Very good. Soon after we divide, we have to reduce. We have to reduce. We're going to reduce 4/6 as 2/3. And then reduce 9/6 as 3/2. After reduce, if we still have denominators, we are going to slide it back. Yeah, so slide, divide, slide. The last step is to slide back the denominator if we still have any. So the final answer is 3x minus 2 times 2x minus 3. That is so-called slide, divide, slide method to factor a quadratic trinomial with a leading coefficient different from 1. Any questions? If not, number 34. X squared minus 25. X squared minus 25 is a binomial, right? Good. Look at the structure of this binomial. Think about the special factoring. In 5.3, section 5.3, we have learned a few formulas that could help us to factor some special binomial or trinomial. This binomial is special because it is a difference of 2 squares. Right? Hope you see it already. It's a difference of 2 squares, right? It's the square of x minus square of 5, right? Square of blue minus square of green. Yeah, it's the square of x minus square of 5. So that's good? Do you guys remember the formula of the special factoring. The formula is x squared minus y squared equals x minus y times x plus y, right? Yeah. So the factorization would be blue plus green, or blue minus green, times x plus green. X minus 5 times x plus 5. Yeah, blue minus green times blue plus green. Here we go. That's the factorization of this binomial. The binomial is special. It's a difference of two squares. Any questions? If not, let's look at number, that's number 34, right? Yeah. So let's look at number 35. Number 35. You allow me to erase those stuff. If you watch the video, you can go back for the content that I'm erasing right now. Number 35. Find all numbers not in the domain of the function. So the function that is given in number 35 is a rational function. Rational function. On the right-hand side of the function, we have a rational expression. Rational expression is a quotient of two polynomials. Numerator 7 is a monomial with degree 0. Denominator x plus 5 is a binomial with degree 1. So it's a rational function, rational expression. We need to find all numbers not in the domain of the function. Okay, is the function has a denominator? Yeah, x plus 5 is a denominator, right? Denominator can never be 0. We all know that, right? Denominator could never be 0. So x plus 5 cannot be 0. Minus 5 from both sides, we have x cannot be -5, right? So -5 is the number which is not in the domain. A faster way to find the excluded value is to write the denominator as x parentheses is one binomial factor. Inside the binomial factor, we have x plus 5. You see the plus 5 in red, right? What's the opposite of plus 5? The opposite is -5. So that's the value you need to select. Yeah, that's the value will make the denominator be 0. Yeah, either way, it won't take too much time. So number 35, find the value which will not in the domain. Just to make sure the value will make the denominator be 0. So you do not want that value because the value will make the denominator 0, make the function undefined. Number 36, express the rational expression in lowest term. Okay, so that's simple. You have a y plus 7 times y minus 6 in the numerator. Numerator is already factored. Yeah, numerator is a factored polynomial. Denominator is also factored. Y minus 6 times y plus 8. Look at this rational expression. Reducing a rational expression in essence is the same with reducing a fraction. Look at the numerator and the denominator. Do we see any common factor? Do we have any common factor? They are gone, right? They cancel each other. So the reduced form will be y plus 7 over y plus 8. Y plus 7 all over y plus 8, right? I think it's pretty simple, pretty straightforward. Number 37. I will have to erase those to get more space. You rewind the video, then you can see those things that I erased. Number 37. We are multiplying two rational expressions is not challenging at all because both of the two rational expressions, I'm going to just use this to explain because it's so straightforward. Number 37, we have a rational expression multiplied by another rational expression, right? It is very simple because both of the two rational expressions have been factored. All the numerators, all the denominators, yeah, they all have been factored. So when we multiply two rational expressions, it's very similar with multiplying two fractions. We simplify before multiply. How do we simplify? We do vertical, vertical, diagonal, diagonal. Remember that? So vertical, we get rid of those two, right? X minus 2, x minus 2, right? Yeah. The second vertical, nothing. Diagonal, left bottom to right top. Left bottom to right top. Those two are gone, right? Right top, left bottom. Those two are gone, right? So after you cancel all the common factors, vertical, vertical, diagonal, diagonal, only two factors left. Yeah, one is on the top, x minus 10. The other is on the bottom, x plus 6. So pretty straightforward, right? Yeah, I believe you won't miss this one. You shouldn't miss this one. And let me know if you have any questions. Number 37. If not, let's look at number 38. Number 38 is to divide two rational expressions. Also straightforward because you don't have to factor those numerators and denominators. Those numerators and denominators have been already factored. So the first thing you need to do is to keep change flip to convert the division to its equivalent multiplication. All right? You keep the first fraction, change the division to multiplication, flip the second. And then you do vertical, vertical, diagonal, diagonal. Vertical, nothing for the first vertical. Second vertical, nothing. Diagonally, you can see diagonally these two guys are cancelled, right? X plus 1, x plus 1. The other diagonal, you have x minus 4, x minus 4, x plus 6, x plus 6. They are all cancelled, right? Yeah, so the only leftover factor in the numerator is x minus 7. The only factor in the denominator is 2x plus 7. And that's your result. That's your answer for these problems. For this problem. Yeah, also very straightforward. Let's see number 39. Perform the indicated operation and express in lowest terms. So if you have 1 plus a, you have 3 plus a, 1 over, sorry. If you have a 1 over 8 and a 3 over 8, how do you add them up? If you add two fractions with the same denominator, you keep the denominator, solve the top, and reduce your result, right? Same with the 39. Yeah, 39, you have two rational expressions you need to add up. You need to take the sum for. And they have the same denominators. You see, 9x, 9x, right? So you keep the denominator, solve the top, 2 plus 8, which is 10. So the result is 10 over 9x. Straightforward, right? Okay. Number 40, add or subtract as indicated. So let me write this one here, number 40. We're going to add a 4 over x and 5 over 7x together. Do the two denominators the same? Do they have the same denominator? No. So we need to find their least common denominator, right? Yeah. The least common denominator of the two expressions is the least common multiple of the two denominators. What's the least common multiple of x and 7x? Not the GCF anymore. We are looking for LCM. 7x, right? Because the 7x is a multiple of x. X is a factor of 7x. That's special case number 1. So LCM would be the multiple, 7x. Very good. Once we found the least common multiple, we are going to write both rational expressions as their equivalent rational expressions with the denominator 7x. Let's see. How do we go from x to 7x? Yeah. So how do we go from what factor is missing in order to go from x to 7x? 7 is missing. So we're going to multiply both top and bottom by 7. Yeah. The factor 7 is missing. So we multiply both numerator and denominator by 7. Then the denominator would be 7 times x. Numerator would be 28, right? 4 times 7 is 28. Okay. Now they have the same denominators. We keep the denominator, solve the top. 28 plus 5. What is 28 plus 5? Over 7x. That's the final answer, right? Questions? Yeah, you just need to repeat. Repetition makes a difference. When you repeat many, many times, when you repeat enough, it's really hard to forget or not understand. Not much like a fancy trick. Repetition is how you get it. Number 41, we need to add 3 over x and 9 over x minus 8. Let's see how do we handle this addition. Do they have the same denominator? No. Then we need to find the least common denominator. The least common denominator is the least common multiple of x and x minus 8. You see, I use a parenthesis to frame x minus 8. So let me color them different. So the two denominators are blue and green. What's the least common multiple of the green, blue and green? Just x? No. Look at the blue and the green. Are they mutually prime? No. Yeah. Are they mutually prime? The blue and the green, are they mutually prime? Yes, they are mutually prime. In the case of mutually prime, GCF is 1. LCM is what? Is their product. Blue times green. We have talked about this many, many, many times. I believe not repeated enough yet. So blue and green are mutually prime. The LCM of them is their product, right? Okay, so now we found, Max, is that clear? Yeah, so now we found the least common multiple, or the least common denominator. We are going to write both fractions as something over x times x minus 8. X times x minus 8. All right, let's see. So I'm going to color this as orange. From the blue to the orange, what is missing? From the blue denominator x to the orange denominator x times x minus 8, what is missing? Yeah, x minus a is missing. So we multiply by x minus a, x minus a. Yeah, we multiply both top and the bottom by x minus a. Yeah, multiply both top and the bottom by x minus a. For the second rational expression, the denominator is x minus a. From the green denominator to the orange denominator, which factor is missing? X. So we multiply both top and the bottom by x, right? Very good. So the numerator is 9x. Yeah, make sure you see what happened here. Yes? Yeah, now they have the same denominator. We keep the denominator. We solve the top. 3 times x minus a plus 9x. We need to simplify the numerator. Distribute 3 times x, 3x. 3 times negative 8, negative 24. Plus 9x. Denominator is x times x minus 8. I do not rush to expand because I need to keep both top and bottom as a factor form to know, in order to know, could I reduce the rational expression or not. So the numerator, 3x plus 9x, 12x minus 24, all over x times x minus 8. How do you factor the numerator? 12x minus 24. Could we factor 12 out? Then inside the parentheses, we have x minus 2, right? Yeah, turns out we have nothing to reduce, but we wouldn't know unless we factor the numerator and denominator, right? Yeah, so either this or this, they are correct. That's number 41. Number 42, simplify complex fraction. In order to simplify this complex fraction, we are applying the second method we learned from the class. We find out we need to look for the LCM of all the denominators. In the complex fraction, we have those small denominators, x, 6, and 3. We get their least common multiple is 6x, okay? And then we're going to multiply each single term in the complex fraction by 6x. And look at this part. Look at the blue part. 2 times 6x gives us 12x, right? And look at this part. 4 over x times 6x over 1. X and x canceled each other diagonally. Do you see what I'm talking about? So these two, x and x, they cancel each other, right? Yeah, so we have 24 left for the second term in the top. The term on the bottom, diagonally we cancel 6 and 6. So we have x times x, which is x squared. And the second term in the bottom, 3 and 6. 6 over 3 is 2. So we have 2x after simplifying. And we factor the numerator and the denominator. Numerator is 12 times x plus 2. We factor 12 out. Denominator, we factor x out. After we factor the both top and the bottom, we see they have a common factor x plus 2, right? They cancel each other. We have 12 over x. 12 over x. So that is 42. Simplify the complex fraction. 43. Solving a rational equation. We have a 5-step procedure to solve a rational equation. Step 1, factor all the denominators. You see x minus 3. If the denominator is a prime, still use a parenthesis to frame it. And x, and on the right-hand side, the denominator is x times x minus 3. X squared minus 3x, we factor x out, we have x times x minus 3. All right? So I want to rewrite the denominators in this way. I'm going to write the denominator as x minus 3. Minus 3 is in red. X minus 3 is in red. And if it's x, I'm going to write x minus 0. So here we have x minus 3 times x minus 0 again. All right, do you see those numbers in red? Negative 0 and negative 3. What's their opposites? Positive 0. Yeah. So yeah, here I write this denominator as x minus 0 times x minus 3, right? Yeah. So the opposites of those numbers in red is a positive 0 and a positive 3. That is those are the excluded values. We have 2 excluded values, 0 and 3. So that's the trick. How do we identify the excluded values? That's the first step. We have to factor. We have to factor all the denominators in order to identify the excluded value or values. So once again, we have 2 excluded values here. Step 2 is to find the LCM of the 3 denominators. And in this case, we actually use both special case number 1 and special case number 2. This guy, x times x minus 3, is a multiple of x, is a multiple of x minus 3 inside the parentheses. So by the special case number 1, that guy is the LCM, right? Yeah? Yes or no? Yeah. Because the orange polynomial is a multiple of both, multiple of x, multiple of x minus 3. Okay, so that's special case number 1 actually. And then we are going to multiply each single term in the equation by the LCM. We have this, and this. Yeah. So let's look at them separately. Look at the yellow part right now. Diagonally, could we cancel x minus 3, x minus 3? So the leftover is 5x, right? Yeah, so that's the first term. Second term, look at the yellow part. We are able to cancel x and x diagonally, right? And the leftover is 9 times x minus 3. On the right-hand side, diagonally, we are able to cancel x times x minus 3, x times x minus 3. The whole denominator are gone. Denominator is gone. So we have a negative 27 left. Once we get rid of the denominator, we have a regular equation. And we solve this equation for x. The proposed solution for x is 0. That's the step 4. Step 5, very, very important. We have to check the proposed solution to get rid of the potential extraneous solution. How do we check? The checking part actually is pretty simple. Look at our proposed solution and the 2 excluded values we found in step 1. Do you see any contradiction? In the excluded value, we have x not equal to 0, not equal to 3, right? But from step 4, you got x equals 2. Sorry, x equals 0. Yeah, x equals 0. So those 2 are contradiction. So it means x equals 0 is extraneous. You have to give it up. The only possible solution turns out to be an extraneous solution. So the original equation has no solution. Solution C is empty. That is 43. 44. What's the square root of 25? What's the square root of negative 16? 94? 94 times 94 is a positive 16. Yeah, what's the square root of negative 16? Non-real, remember? Square root of a negative number is non-real. Yeah, so if you see a square root of a negative number, choose non-real, period. Simplify square root of 20. Is 20 a perfect square? If not, put it down big L. This is the technique, super important. We learn this technique the first class of this semester. Divide by 2, we have 10. Divide by 2, we have 5. So 20 is 2 square times 5. Square root of 20 is square root of 2 square times 5. Are we able to move the 2 in red outside the square root? Because again, it has a square on its shoulder, right? Yeah, I think if you pay attention in the class, the same process we have repeated so many times, I really think you should get it. If you move the 2 out, you have 2 times square root of 5, right? 5 must stay because the 5 has no square on its shoulder. So that's how do we simplify a square root. Number 47. Number 47. Do you guys remember the test 5 we just done? You guys ask 72 x squared, right? So I simply just switch the order. Oh no, actually it's exactly the same, 27x squared. You guys asked this problem in test 5 actually. So let's see how do we simplify 47. Is square root 27x squared. The the radicand is a monomial. The monomial has a numerical part and a variable part, right? We deal with the numerical part and the variable part separately. 27, we put it on big L. We have 27 equals 3 times 3 times 3. So we write 27 as 3 square times 3. And x squared itself is a perfect square, so x squared. Could we move 3 in red out? Move the x in red out? 3 and x are red, right? Could we move them out? Yeah, because they have a square. And do we still have something under the square rule? And that's the result. Yeah, some of you struggled in test 5. It's pretty simple, actually. Pretty simple. You just need to deal with the numerical part and the variable part separately. 28. Simplify 2 square root 5 minus 7 square root 5. So you are subtracting 2 square roots. Question: are those 2 square roots like radicals? Are they like radicals? Yes. If they are like radicals, we can combine them. We combine like radicals by combining their coefficients. The coefficients of the first radical is 2. Second is -7. 2 minus 7, -5. So we have -5 times root 5. Very straightforward, right? Yeah. Next one, 49. What is root 2 times root 3? The formula you need to know is root a times root b equals root times square root of a times square root of b equals square root of a times b. Here, both a and b must be positive. So square root of 2 times square root of 3 would be square root of 2 times 3, right? And that is square root of 6, correct? Very straightforward, super simple. The last one, number 50. Rationalize 1 over root 2. Rationalize the denominator. What's the conjugate of root 2? If you see root 2 as root 2 plus root 0, the conjugate would be root 2 minus root 0, right? Yeah? And what is root 0? Square root of 0 is just 0, right? Yeah. So square root 2, the conjugate of square root 2 is itself. You multiply both top and bottom by root 2. Numerator is root 2. Denominator, what is root 2 times root 2? Here we go. That's how do you rationalize the denominator. If the denominator is one single square root, the conjugate is itself. All right, let me stop the video.